In the name of God. Hello, everyone. Welcome back to Ferho's website. It's me, Masoud. I'm a physics teacher. Uh, Today, I'm gonna explain new subject, which is about the centripetal force at poles and equator. There are some notes about this subject. Let's say the notes are separated into two parts. The first part, two notes about the, let's say, information about the poles, actually at poles. And the second part of these notes is dedicated for the information within the equator or in the equator. Here, I want to appreciate Mr. Kamal, one of my friends and uh, colleagues. Actually, he's one of my coworker. He helped me to collect these information. He told me, let's say, these notes, and I collected these notes, and I prepared it here. I drew the figure, and I'm at your service to explain these notes for you. And there is a question of national exam about this subject. That's why, let's say, pay attention to, let's say, to explain this subject. Number one, objects tend to be heavier than in the equator. Objects tend to be heavier, let's say, than in the equator because in the poles, Earth has a small radius, Fg is maximum. What does it mean? Objects tend to be heavier, let's say, heavier in the equator than in the poles. Excuse me, let me read the title with the note, right? It's pointless without the title. In both poles of Earth, right? This is the full sentence. In both poles of Earth, objects tend to be heavier than in the equator. So what does it mean? Here, let's say North Pole and South Pole. Objects here tend to be heavier than equator because what? Because in the poles, Earth has a small radius. So the radius of Earth here is smaller than the radius of itself, let's say, in equator. So here there's a, let's say, large radius, right? Large radius in equator, small radius in pole. It's not just for North Pole, it's true for South Pole as well, right? So that's why I can say Earth resembles an orange, right? Earth resembles an orange. It's not a perfect circular object, it's a sphere. Our globe is a sphere. What does it mean? It resembles an orange because orange bulges at the center. And it's true for Earth as well. Earth sticks out at the equator, right? It's not a perfect circle. If you measure the radius of Earth from the center to the equator, you find that the radius of Earth at the equator is greater than the radius of Earth from the center to the pole. That's why Earth bulges at the equator. Earth sticks out at the equator like an orange. So the shape of the Earth is, let's say, is just like the orange. The shape of the Earth uh, resembles an orange, and its orbit resembles an egg, right? It's an egg-shaped or oval or elliptical, semicircular, right? But the shape of Earth is an orange. It's like an orange, right? So here, that's why actually, because of the rotation of Earth during billions of years, Earth bulges at equator. That's why Earth has two radius. One radius is larger than the other. Which one is larger? Guess the answer. So the radius from the center to the equator is longer than the radius of Earth from the center to the pole because of the Earth rotation, because inertia, look here, because inertia of these, let's say, locations, inertia of these regions, I'm talking about the equator, inertia of these, let's say, territories, I can say, overcome the centripetal force of Earth, overcomes the gravity. That's why during billions of years, it bulges, let's say, at the equator. This is an introduction of this subject, actually. And we can say Fg is maximum at pole. Actually, because the distance, because the Earth at the pole has a small radius, that's why Fg is maximum here. Keep in mind that Fg at pole is maximum because it's closer to the center. Based on which equation? Based on this equation. Fg is equal to G capital M1, M2 divided by R squared. Based on universal law of gravitation, Fg is inversely proportional to R. That's why the smaller the radius is, the greater the gravitational force is, the greater the weight is. That's why the weight of a person or an object is maximum at poles because it's closer to the center based on this equation, right? So, but the second note, in both poles of Earth, there is no centripetal force. Fc is equal to 0. There's no centripetal force. Why? Because tangential velocity is equal to 0. There's no tangential, because tangential speed or tangential velocity is equal to 0 at every point in that region. At every point in this region, in North Pole and South Pole, actually, there's no tangential velocity. That's why Vt is equal to 0. Whenever the Vt is equal to 0, so 0 Vt leads to what? 0 Vt leads to 0 centripetal force. Based on which equation, teacher? Based on this equation. Fc is equal to mVt squared over R, right? So whenever Vt is equal to 0, automatically Fc becomes 0 because mass and radius never be 0. That's why Fc becomes 0. So keep in mind that at both poles, Fg is maximum, weight of the object is maximum, but centripetal force is 0. There is no centripetal force. This is about the poles. Let's move on to the equator. In equator, right? In equator. And you know, equator is the longest latitude of Earth. Latitude, I mean horizontal lines of Earth, right? They are imaginary, horizontal imaginary lines of Earth. They are called latitude. The longest latitude is called equator, right? And it's drawn from what? From the east to west, right? From east to west of Earth, I can say. Equator, let's say, divides the Earth into two hemispheres, into north hemisphere and south hemisphere. Anyway, so in equator, objects tend to be lighter. Look here. In equator, objects tend to be lighter than, excuse me, let me read it again. In equator, objects tend to be lighter than in the poles, right? So here, in the equator, objects tend to be lighter than in the poles. Why? Because of this previous reason. Because, let's say, because of the, let's say, because here in this region, the radius of Earth is large. Because objects, let's say, get farther from the center of Earth. That's why I can say objects, let's say, seem lighter. Objects seem lighter, let's say, than in the poles. Because at the equator, Earth has a larger radius. Based on the previous, let's say, reason. The second note, centripetal force Fc is maximum. Look here. So we said that centripetal force at poles, North Pole and South Pole, is 0. But here I say centripetal force is maximum, Fc is maximum. But Fg is minimum. Why Fg is minimum? Because the radius of Earth is very large. And you know that Fg is inversely proportional to radius squared based on this equation, universal law of equation. And I told you, let's say the larger, here I'm talking about the equator. The larger the radius is, let's say the less the weight is, the less the gravitational force is. That's why objects seem lighter here than the poles. But Fc is maximum because I told you, because of the Earth rotation during billions of years, points or territories located in this location, like Brazil, for example, some countries are located at the equator. These countries, during, let's say, billions of years, I can say tangential velocity of these regions, let's say, because of the actually inertia of these regions, they get tangential velocity and they stick out, they bulge at this equation, and these territories get farther from the center of Earth. That's why the farther the let's say the farther the position, the point is from the center of Earth, the less the weight is, the less the gravitational force is. This is actually an explanation of this, let's say, subject. Number 2, centripetal force Fc is maximum. Yeah, I explained it, and I told you this is Mr. Kamal's notes about the centripetal force. I appreciate him. That's it. Let me read the question. Has to do with this subject, and is the question of national exam. Let me read the let's say question for you, and I want you to guess the answer. There are questions about this subject. There are 3 questions. Question number 1: because of Earth rotation, you would weigh slightly less at the equator than you would at the poles. Yeah, I explained it for you. Because centripetal force is, look here, because of Earth rotation, you would weigh slightly less. You would weigh slightly less. You weigh less actually at the equator than the poles. Why? Because centripetal force, Fc. Because Fc is, question focuses on Fc, because Fc is maximum at the equator, maximum at poles. I told you at poles there is no Fc, so it's completely wrong. But we are doubtful about this one. Yeah, right now I want you to think about it. Maximum at equator, and equator and poles are opposite, right? Anything about the equator, anything true about equator, let's say any information about equator, I want you to make it opposite for the poles. That's why till now A is true. C, Fc the same across the latitude, horizontal lines I told you, and the equator is the longest latitude. No, it's not the same. Fc is not the same actually. It says Fc is the same across the latitude, horizontal lines. Let's say because it changes from position to position, it changes. That's why it doesn't add up. D, the same on equator and poles. So it's completely wrong. We don't accept it. Only A is true. This is the question of national exam. Focus on it and take care of, let's say, focus on it and memorize it as your names. Question number 2. In a flat circular path, the only force that maintains circular motion of an object moving in a circle is, so, friction or normal force. In a flat circular track, what's the meaning of flat circular track? Means there's no sharp turn. It's an ordinary, let's say, circular track. Think about the circular path of a car, for example. Think about the square in your city, actually. In this situation, it's a flat circular track. So which force is in charge of, let's say, which force is in charge of creating, let's say, centripetal force? Which force is in charge of moving the objects around the circle, right? Is it friction or normal force? Of course, friction. Keep in mind that whenever you hear the word flat circular path means ordinary. It's a normal circular path. That's why for flat circular path, friction is in charge of creating, let's say, uh, centripetal force, right? Friction, uh, let's say, in flat circular track will be centripetal force. But one more question, question number 3. In a banked curve, what's in a banked curve? Means sharp turn. It's not an ordinary turn. Maybe there's a defile, maybe in a mountain, and maybe it's the mountain, in a mountain road, there are a lot of defiles. And in this situation, sharp turn or banked curve, the only force that maintains circular motion of object is in a circle. Actually, is it friction or normal force? No. In a sharp turn, actually, uh, friction is not enough. Friction cannot keep the object in a circular track. That's why I can say in a defile, especially in mountain roads and in defile, friction, let's say, approaches zero. So the only force that keeps the object, let's say, its circular track, yeah, that keeps the object in its circular track is only normal force. So that's it, guys, for today. I hope you enjoyed this lecture, and bye for now.